7.3 electric fields. So we know the electric force between the two charges Q1 and Q2 is KQ1 Q2 divided by R power 2 distance squared the distance between them. So any charge has a field, create a field around it. That's why the charge exert force on each other. How they communicate? They communicate by their field that is around them. So positive charge, the field will go out of that. For negative charge, the field go into the charge. And this is the shape. Electric field is force per unit charge. So force divided by Q. You know where the force is KQ1, Q2 divided by R2. And if you divide it by Q, so these Q and Q cancel, and this is what we have. Electric force is KQ1 R2. Make sure this Q1 is a charge there. This is the electric field that the charge Q1 will form around itself. If two charges interacting with each other, two charges are positive, we know that they repel each other. Now look at the shape of their electric field. Their electric field kind of repel, right? So this is repelled by this. That kind of shape will be formed. Now, if the charges are opposite, they attract it to each other. Therefore, their electric field interact in such a way that they are attracted to each other. Such a things. Well, as you see, this is out of the positive and it's going into the negative charge. If you have two plates, parallel plates, one of them is positive and one of them is negative, the electric field will form is out of positive into the negative. So, and it will be uniform in the middle, but at the edges, as you see, there is kind of this bending. Look at this question. What is the electric field of 0.6 meter away from a small sphere with a positive charges of the 1.2? So Q is given, R is given. We want to find electric field. E is equal to KQR2. K is a constant. We know Q, we know. R, we know. So we just sub in and find electric field. Make sure electric field is the vector. Two charges, one is positive 3.3 10 power negative 9 and other is negative 6.4 10 power negative 9 or 42 centimeter apart. Make sure we convert to centimeter to meter. Calculate the net electric field at point P. A positive charge on the line connected. Okay. You want to find the electric field. So from positive charge, so to find the direction of electric field, just every time assume charge Q positive is placed there. So since this is positive, they repel. Therefore, E1 gonna be away from that. So it's pushing this away because it's assumed to be positive charge. You put a test positive charge. In practical, there's nothing here. Now again, positive charge, you put it there, so it's negative. Negative is attracted to the positive, right? The positive attracted to this. The direction of electric field from charge Q2 is going to be, again, to the right. So it's easy now. We calculate the magnitude of E1, KQ1. Q1 is 3.2 10 power negative 9. Just put it there. R is 0.15 centimeter. Okay, maybe this is the middle, means the distance, you need to half the distance, 42 divided by 2, and then turn it into meter, centimeter to meter. So let's just clear that. Same thing. We have R2. Okay, just make sure it's 15 centimeter from the positive charge. So here is from positive charge is 15 centimeter, and 42 minus 15 is 27. It's 27 from the negative charge, right? Therefore, the electric field is given to you. No, because this electric field is both in the same direction, you add on. That's going to be not right. So here's another. The magnitude of the electric field between the plates of parallel plates capacitors is 3.2 10 power 2 Newton per coulomb. So this is electric field. What happened if the charge on each plate were doubled? We know the electric field is proportional to Q. If this is doubled, the charge doubled, of course, the electric field will double. So you just multiply it by 2. If the plate separation were to triple, so you know the separation between plate not going to affect the strength of the electric field. So it's nothing going to change. So to practice, do question number 1, 2, 3 here, and question 4 and 5 and 6.